Let's swipe the camera. So, hello guys, welcome to this video, random video, night video actually. So, yeah, I thought these kinds of videos where we chit chat for a short period of time, explaining a topic or talking about it. Uh, Maybe I have some information that is wrong and I want to correct it. And I think one of the best ways to learn is to educate or explain because you need to know the thing to explain it to somebody. And if they know the thing that you're explaining and you made a mistake, they can correct you and so on. Never be afraid to make a mistake in your professional career, actually, because mistakes are how we learn, okay? And if anybody tries to shame you for your mistake, just don't take it. Don't take that shame, okay? I don't know who said this quote, Seneca or uh, I don't know the name of the philosopher to be honest. Like I have a Seneca's book here. I mean, just here. I read. I read this Seneca's book, and it's a very good book to be honest. Now I suggest it to everyone to read it, which is it's not. I'm just gonna explain the context. I don't remember the exact quote, but the content says that it's not the actions of others that hurts us, but how we interpret those actions or how we perceive them or how we see them. That's what really causes harm. We suffer in imagination more than reality. So, anyway, enough philosophy for today. Um, I want to explain in this video what is context switching, all right? And why do I want to explain this thing? It's because I'm watching the OS course by Hussein Nasser, and I think this guy is very good and very underrated because his courses are amazing. And I don't see much people talk about them on social media, on Twitter, for example. This guy knows his stuff, okay? I'm not gonna say knows his stuff. He's always admitting that he has black boxes that he always wants to explore, and that's the beauty of learning. Anyway, I really advise you to go watch this course. I'm not paid or anything. I just bought it. I usually prefer books or and articles, but when it comes to Hussein Nasser, I have no problem in watching hours of his content. I really made a long introduction here, but let's get to the point. Context switching. So, to really know what context switching is, we need to know what is a core in the CPU. And of course, please correct me if I'm wrong in the comment section or private messages or whatever. I'm always open to knowing more and correct my mistakes. So a core can execute only one process at a time. And a process, it's a very big topic. It has its own thing, but let's leave it after, okay? Because we need to explore what a process is and what's all of its components. Context switching, a core can execute only one process at a time. And imagine this, if I'm sprinting, I'm doing a sprint in a competition, and they need to record me. For example, they need to know my weight, my length, what is the time that I did in that sprint. If I stopped, where did I stop? Uh, what exact place did I stop in? It's the same thing for a process. It's executing. We need to track it. We need to know which memory addresses it uses so we can access them. We need to know its process ID, we need to know its state. I'm not gonna talk about registers and TLB and all of that stuff. Let's just, that's another black box. We need to explain the entire concept of a core and the process to get to know these things. But let's just simplify stuff. As I said, it has its own things to track it down and know, uh, because each process is just an instance of a program. So the instance of a program is just going and executing commands or not commands, instructions, let's say. For example, in assembly, we have add and load and yeah, a lot of different stuff. I don't know a lot of assembly, to be honest. I'm learning it. I haven't looked at anything about assembly from my third college year. Uh, it's been a long time. Anyway, and this process is executing on the core. In Windows 3.1, they had this bug where if you give to the core a process to execute, which is which lives in the kernel, okay? The kernel is the one that tells the core or the CPU what to do. When I say core, it's just inside the CPU, a core in a CPU. Like, it's not something else. In Windows 3.1, they had this bug where they had, let's say, for example, two processes, one that's very long and one that's short, or let's say long again. We don't care about the second one's length. Let's talk about the first one. It takes a long time to finish, and the core is going and executing this, tan, 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 tan. But the other process is not getting any execution time. It's there. Like if you click a program and the core was executing something, you see that program as freezed. It doesn't do anything. And that's problematic to the user experience. I have no problem if it gets opened slower or picked up slower in the CPU, but I need to see some interactivity. I need the process to execute. Like there are programs who do that thing asynchronously. When you open them, they load all of their stuff and so on asynchronously. I don't know which program does this. I think it's Chrome, I guess. Yeah, I don't really remember which program exactly did this thing. But anyway, as I said, it's there. So we use a term called process starving. It's not getting any execution time on the core. All right, so one is getting all the execution, all the stuff happening in there. It's really living in heaven, but the other one is not getting anything. And that caused a bug. So we thought about this thing called context switching, where you do basically concurrency. For those who don't know what concurrency is that you don't execute two things in parallel, because as we said, a core can execute only one process at a time. We execute one a little bit, then execute the second one a little bit, then execute the third one a little bit, the first one a little bit, and we go on. So on and so on. So we give them an execution time for each one. So we create the illusion of the things executing faster. We're not freezing, but instead we're just switching them. Okay? I'm trying to avoid too much technicalities here, because if I mention anything, it's a black box. If I say the TLB, you need to know virtual memory in order to know the TLB and so on. That's very complex. We can do a lot of videos about this thing in the future. I have no problem. Anyway, where were we? Yeah. So we made this thing called context switching, where we switch between processes. And there are a lot of algorithms. There is round robin. I guess Linux uses something called the CFS. I don't really remember. Let me get it from my notes. Notion is very good software. Yes, the CFS. It is in front of me. Because I was reading the book, the XV6, which is a learning implementation of the kernel, which was just for people to learn how the things works. The name of the book is, just type book risk v rev 3, I don't know, just xv6, and it will pop up. You can read the book, and there is a repository written in C also. So the algorithm that Linux uses is a completely fair scheduler, which is the CFS. I guess, if I remember, because I read an article about it not so long ago, to be honest, but I just don't remember. I don't pursue learning as a task. I pursue it as fun, doing it for fun, which it was just to know which one did not get a fair share on execution time. I'm saying execution time, but it's just instructions, okay? There is no time. Each instruction might take a different time, because we might have a function that's living there in the memory. There is a travel time in the stack to read this memory space, so yeah, we could have the core waiting for a long time. So when I say execution time, it's just how many instructions it gets, I guess. Yeah. To me, those things are black boxes at the moment. I don't really know too much about them. So yeah, I hope it's clear, and it was worth this time. It was worth your time. This 13 minutes, I guess. And yeah, see you in another video.